Hello, everyone. The title of this presentation is I Interned at a Big Tech Company So You Don't Have to. SWE Best Practices and How to Not Suck at Your Job briefly. So real quick, I'm going to go through a bunch of material in this talk. So I actually wrote this up as a blog post, and it's at this URL. So if somebody wants to go to that URL and tell me if that link works, and if you see like a written up version with like the same title, please let me know. Thank you, Archie. It is a very funny title. That is why I chose it. But yeah, just let me know what you get when you go to that website.
LOL, don't have Twitter.
Got him. Okay. Twitter. Yeah. Hello. Hi. It links to my Twitter. Please follow me on Twitter. I'm very funny. I'm also very topical. So yeah, if you're interested in tech or anything else that I might potentially be interested in, feel free to throw me a follow. With that, hello, hi, I'm Ali. So I am a senior at Rutgers. I'm a program manager at a social impact in tech organization called Impact Labs. I used to be president of USACS. In addition to all of that, I was I still am a coach with Major League Hacking, an incoming full-time employee at Microsoft as a software engineer, and a former Pearson K-12 intern. Some fun facts: I like DevOps, infrastructure, distributed systemsy stuff. I also like philosophy, poetry, and tabletop role-playing games. So now that you adequately know enough about me, let's get into the content of this technical talk. So first and foremost, I kind of want to just like start with like an introspection as to why people like study CS or learn how to code, and like the biggest aspiration of a lot of people who study CS is like working at a big tech company. So I kind of want to ask the question, why should I intern/work at a big tech company? So there are a couple of reasons. Number one is money. These companies pay very well. Number two is clout. Your peers will think you are a very cool TM because you work at, I don't know, Fang or some other really big tech company. To make the world a better place, these are huge companies with like really big impact and products that touch the lives of millions, if not billions of people. And then finally to become a better engineer, and to just get like good at code. So first and foremost, if you are looking to enter at a big tech company for money, you are petite bourgeois scum, and I don't like you. Similarly, if you are looking to enter at a big tech company for clout, you are petite bourgeois scum, and I don't like you. And if you're looking to enter at a big tech company because you want to make the world a better place, you are lying, delusional, petite bourgeois scum, and I don't like you. So that leaves you with one good reason to work at a big tech company, which is to become a better engineer. Obviously, this is a joke. LOLXD, I'm kidding. Ha 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 ha. But I'm not saying that like money and like the respect of your peers and impact are not like, I'm not saying that they're not good reasons to work at a big tech company, but I think that those are kind of like misguided. And like the only great reason to work at a tech company like Facebook or Google or even Microsoft is to like become a better engineer. There's a lot that you can learn from a company that's been around a while and has really big products. So I think that the mindset that you should go into when pursuing a job is to like get better at what you do, as opposed to anything that's sort of like circumstantial or like around that. Cool. Now that I'm done with that, can you see an iCloud storage notification on my screen, by the way?
Yes.
Yeah.
Fire. Let's click manage and then just completely ignore that. So then the next question is, why should I care about SWE best practices? Because it can get you hired at a big tech company. A lot of places, when you apply to work there, will probably look at your side projects or your GitHub or any of the stuff that's on your resume. So if you can show them that you have a lot of the skills that you'd probably learn while working there anyway, it'll make your chances of getting hired a lot easier. I found that in my experience, I kind of struggled to talk about my work and like what it looked like. And when I first got to Microsoft as an intern this summer, I struggled a lot with like the whole like, oh shit, I have to write good code for the first time in my life. And it took like a while to get like up to speed on that. So the sooner that you learn this stuff, the better. Quick forward. At its core, software engineering best practices are about communication. Your code should be on some level modular, self-documenting, and easily modifiable. So the reason for that is super simple. Yeah, the reason for that is super simple. Like at a big tech company or even a small tech company or whatever, the assumption is that the company is going to be around forever, which means that like hypothetically, or in my case, practically, when I worked at Microsoft, I was looking at code that was like minimum 1 year old and potentially up to like 10, 15 years old, right? Like you want your code to be as easy to read and change as possible, just because like number one, you're not going to be the only person looking at this code. Number two, like if the older the code gets, like the easier it is to read and change, the better it is for everyone. There's this like concept called technical debt. You can look it up on your own time. Basically, if someone leaves the company or if someone switches teams or organizations or something, and their code is not well documented, your engineering time is spent like learning what this code is, as opposed to like building it and changing it the way that it needs to be changed to fit whatever use case you need. So communication, super important in software engineering. So here is a brief table of contents of what I'm going to be covering today. Number one, the case for object-oriented programming. Number two, the case for strict/static typing. Number three, how to use Git, because I know every one of you little shits has put it on your resume and you have no idea what you're doing. And then finally, a general Q&A. Like big sort of asterisk. I'm not going to be like sharing VS Code and like coding out examples for all of that, for all of this stuff. Instead, I'm just going to be like abstractly explaining what it is and why it's useful, because I think that understanding it conceptually is sort of like the first step to understanding it practically. And I don't have enough time to like give full crash courses on each of these things on their own. So without further ado, object-oriented programming. What is OOP? The most prevalent TM paradigm for software engineering in the tech industry, the bane of CS 111, 112, and 213 students. And actually, it's an abstraction of software engineering that focuses on modifying data and information as opposed to modifying processes. And like the benefit of it is that it modularizes your code, and it uses things like classes and interfaces to make them self-documenting, et cetera, et cetera. So let's look at an example. So on the left, we see a class. So classes are basically like collections of information and instructions. So here we have like a basic class for a student. If we wanted to represent what a student is in code, they have a string name, a string grad year, a string residence hall where you live, a string array of their majors, and then a string array of what courses they've taken. They also have a constructor, which will allow you to initialize any student. And it has a helper method called add course, which I did not write the code for, but would probably do something along the lines of this.courses.append course name. So yeah, like the idea here is that once you have initialized a student class, you can basically modify it however you want, with like helper functions. And this sort of like collection is a very like streamlined, clean cut way to write your code. On the other hand, we have interfaces. So if we wanted to create an interface for a student, it would have a string name, string grad year, string res hall, string array major, and string array courses. So does somebody want to tell me either in the chat or over voice how these two things are different? Just a random guess. I'll take a random guess.
You don't instantiate an interface student.
Hell yeah. Thank you, Jonathan. You do not initialize or instantiate an interface student. So an interface is basically just grouped information, whereas a class is grouped information and instructions. So precisely like Jonathan said, you would initialize a student. It has a constructor. So you would be like new student, parentheses, all of the things that you would need to pass to the constructor to initialize one. And then you could hypothetically call student.add course and then pass it a string array to modify it. versus an interface, which is like not necessarily immutable, or I guess the interface itself is immutable. It's basically like a custom type, right? Like if you, who has taken 211 or 214, like comp Parker systems, people are raising their hands. So like the way that I would sort of like describe it is that an interface is very, very similar to type def, right? Where you can basically create like a custom type that like stores a bunch of information. So cool. Classes and interfaces, that's covered. So why object-oriented programming? Number one, it is inherently modular. Number two, it is inherently self-documenting. Number three, some stuff about extensibility and modifiability that I'll get into later. So why is it inherently modular? Because if you write a class that does a thing, that like number one, all the code that manages that thing is in one file, right? So things will work together in their execution, but not in their sort of like definition, right? So if you write a class that does a thing, I'm trying to like think of examples, but it's like escaping me. But like hypothetically speaking, a class should do one thing. And if you have a class that does one thing, and you have a million classes that each do one thing and they all work together, that's like super modular and super good for people who have never seen this code before and vaguely want to learn how it works. Number two, inherently self-documenting. It sort of like ties into how it's modular. So if you have one class that does one specific thing, or like a handful of specific things even, like each of the function names and all of the data, like all kind of makes sense. So if you were to peruse like some random like object-oriented project, you could be like, oh, this does this does that. Here's all the data that I need. Here are all of the operations that I need. And it's a much cleaner way of reading code. I can show some of my, like later on in the presentation, there's like a optional thing where I can show like object-oriented code versus non-object-oriented code, and we can like go through that there. But the idea is like all of the information is in one place. So within like 60 seconds of like scanning a file, you can be like, I vaguely understand how this works. Versus if I just gave you like a Python file and you looked at it, you'd be like, what the fuck is this? Cool. Now on extensibility and modifiability. So extensibility is kind of like this concept of reusing code or making your code extensible. So like if you write some code that does something like with very few modifications or changes, it should be able to also do another thing. So here is an example. Let's say that we have a class server, right? And this is just supposed to hit an API and return some data, right? The constructor will take some endpoint, and this endpoint, this dot endpoint will be endpoint. So yeah, when you initialize a new server, it will take the endpoint or like the part of the database that you want to get information from. So then you have a DB URL and then an endpoint, right? That are the only two properties. And then you have a helper method called call endpoint, which takes something. Thank you, Mania. I also like my graphics. So if you have an endpoint or a helper method, sorry, called call endpoint, right? It can just return an API call of this.db URL / this.endpoint, right? So just like pseudocode, very abstractly, this is a class that initializes a server that if you give it like an endpoint, which is like some like subsection of a data set, it will return the data in that data set, right? So now on the right, we have server A extends server, class server A extends server, right? So right off the bat, this is much smaller than this because all of the code from here is inherited here. This is called inheritance. You're welcome. Roll credits. So yeah, you like the constructor for server A would just be super endpoint. You would give it the same parameters and then super call the constructor in the base class. And then this can be modified as needed, but still retains the helper function, helper method called call endpoint, right? So let's say that here, like server A, you want to test a server. You can add all of the functionality that you need to just to server A to like test server. Does it return a 403 or a 404 error? If so, notify me of that. while also like calling the endpoint and doing all of this stuff that it, excuse me, also needs to do. So I don't know if y'all were looking at my slides, but in case you weren't, this on the left is called the base and or superclass, which is the most like fundamental implementation. And then this on the right is called a subclass, which extends the base class, but modifies it as necessary. Does this make sense to everyone?
Yeah.
Cool. And then the second thing is ease of modification. So this is some code, the same code for class server. So the standard practice for each, like for an object-oriented program, is that each class should have its own file, right? Which means if someone new joins the team, or if someone just like happens to stumble upon this project and is like, hey, I really want to contribute to this, you can just go to the file and modify it, right? Which again, if you have like a super huge monolithic project, is a lot harder, because then you have to like understand the entire repo to make whatever change you need to make. So like in general, make your file smaller. Like if you do things with classes, you can extend them, et cetera, et cetera. They're modular, easy to modify. This is an introductory talk, so I'm not going to like go too deeply into the pitfalls of object-oriented programming, but in general, like the more extended a class becomes, the more kind of like bastardized and difficult to use and inefficient it is. So like it becomes like it's again, at its core, it's about communication, right? If you have a class that extends a class that extends a class that extends a class, someone now needs to understand like all four classes to understand the thing at the end, which is a thing that I experienced at my internship. That being said, this way is still probably better than just having like one big app that runs, and it just runs and you have to understand like everything to make it work. So yeah. Number two, strict/static typing. What is it? It's making sure that each variable is assigned with a type. So I'm going to go out on a limb and guess that everyone in this Zoom call is either in 111, 112, 211, or 214. So 111 data structures, comp-arc systems, right? So most programming languages that you're familiar with through class already use static typing. So like Java and C and stuff, you have to declare like int something or the float something or string something, and so on and so forth. But this sort of like paradigm or concept becomes super necessary in languages like JavaScript and Python that are not like out of the box statically typed to prevent catastrophe. So here's some strict versus non-strict typing. So on the right, we have, or this is the left. On the left, we have some unstrict types, some variables declared with unstrict types, right? So we have x equals 5, y equals some string, z equals true, and d has no value. Wow. And then on the right, we have x is a number, y is a string, z is a Boolean, and then d, even though it's not initialized, has the type of like object. So here's why this is valuable, right? And this is super simple. There's not like much to go into it. Number one, again, inherently self-documenting. If you had like let's go back to this, right? If you had like X, Y, Z, D, right? And then you have some like methods or functions that modify X, Y, Z, and D, right? If someone is looking at that code and they don't see at the very top, like, this is what type this should be, like the operations might not be immediately evident to them. So they might have to like use the debugger and check breakpoints and see what the value of each variable is to understand your code, right? Or they might have to use print statements or something. Like if you're statically declaring variables, it's super easy to know what it does. But if it's like a parameter that gets passed to a function and it doesn't have a type, like truly could be confusing. The other thing is it forces you to write code that works. So usually if a programming language has static typing, it has something called a transpiler or a compiler. So a compiler like Java and C, y'all should be familiar with this. But for programming languages like I think, yeah, Python doesn't compile. Like Python and JavaScript, right? They have something called a transpiler, because since they're not like compiled languages, they're just executed. It sort of like runs a bunch of tests on them first. So if you write code with static types, like if the transpiler catches any errors, it will let you know that like, oh shit, type error, cool, fix this, right? Versus if you're just writing like code that's not typed, very likely that you might like crash and burn and like hit something, and like your code will run and then you'll get a bug while your code is running. And those are usually harder to fix than type errors. Like if like who's taken 112? I'm gonna assume everyone, because everyone's video camera is off, right? If you've taken 112, when you compile your code, Mani, I know you've taken 112. If you it's much easier to catch bugs when you're like Java C something something something, right? And it's like, hey, you have like these 10 errors in these few files, right? Go fix them and then we'll talk. Like versus, oh, cool, null pointer exception on this line, and here's the entire call stack, right? Like one of those is inherently easier to fix than the other. So that's why static types are good. Another thing that makes static typing really, really, really valuable is the concept of truthy values. So let's say that you're writing some program, right? And you're writing it in a not type strict language or a not type safe language like JavaScript, right? In JavaScript, if you have a Boolean, it can be true or false, right? And then true will do something and false will do something. Except there's also like a level of abstraction of something called truthy and falsy. So like, let's say that you have a value of 0, right? Like just the number 0. If you were to like compare that to a Boolean, it would return false, right? So if you were to do 0 and true, it would return false, because in its eyes, 0 is like equivalent to false. Some other equivalences to false are undefined or null, and so on and so forth. So like edge cases will occur often, where quite literally someone will be like, this is a number that's value is 0, and its number and its value is going to change. So I'm going to compare it to something else, and then shock surprise, like if the number doesn't change and it's 0, your like entire thing gets like fucked, because it decides that like 0 is a Boolean, right? And same deal with like undefined or null. So if you like statically type something, that's really, really good, because now you sort of like avoid the risk of like running into like this whole like truthy value dilemma, right? And then going back to interfaces, right, where you can sort of like define your own type and like create an object and then be like, this object fits within the mold of this interface that I designed, right? It makes sure that your data, while it's being like processed or used or modified or whatever, is like sanitized, right? Like it fits the mold. So if there's any sort of discrepancy, like you can throw an error, as opposed to being like, well, shit, this user put in their phone number with something that's like they put in their phone, like for some reason this user typed out their phone number, like they typed out the word 1 and then the word 7, like 01E SEVEN, so on and so forth, right? Like if you're like, hey, my what's it called, like the phone number field should be a number and not a string, then your what's it called, like your interface will catch that. And if you're statically typing, then your transpiler will be like, oh shit, or like in runtime you'll catch an error that's like, oh shit, this person isn't complying, and then you can just throw an error. Cool, that was a lot, sorry. Cool. Next thing, number 3, version control, Git. So what is version control? Number 1, it is how software engineers collaborate. Number 2, it's how to save your repository after you've potentially irrevocably fucked it. And then number 3, it's like the number 1 skill / tool that companies look for while hiring. And there's a couple of reasons for that. So here's how version control works, right? You have some base stable version of your code, which sits on your main / master branch. Society still hasn't decided which one we want to call it, so I'll just be referring to it as main. So yeah, you have some stable version of your code. It sits on something called a main branch, right? Number 2, you will make some changes to your code in small batches, and those are called commits. So like, let's say that I write like I have a file, right? That's just console.log, hello Ollie, and then I commit that. That will sit on master. Now let's say that Archie wants to change it, right? Archie can take my code and be like console.log, hello Archie, and then she can push that, right? Or Sam might be like console.log, hello Sam, and he can push that, right? So as you and your collaborators add more functionality to the code, Git or whatever version control system you're using, such as Mercurial or something else. I'm just going to use Git because that's what I'm most familiar with and what a lot of places use. Not Facebook for some reason, but most places use Git. Git will track your different versions and then will merge them until you and your collaborators like merge them and resolve any merge conflicts, etc., etc. So in the chat, I will be typing out what most people think Git, like how, this is how you use Git. Cool. So if you check the chat, I have put in 3 Git commands: git dot, git commit -m WIP, which stands for work in progress, and then git push origin master, right? Cool. A lot of people think that like Git is just like, cool, I've written a shit ton of code. I'm going to add it all at once and push it. I'm going to add it all at once and push it. I'm going to add it all at once and push it, right? This is not a good way to use Git, and it's not how it's used at most companies, and it's not how it's used in like engineering organizations in general. So this is how you should do version control correctly. So step 1 is create a topic branch, right? So what the fuck? Step 1 is create a topic branch, right? So as I mentioned before, you have a main branch, which is the most stable version of your code, right? So main is a branch. So you can branch off of that, and then you will have something called a topic branch, or you will just have something called a branch, right? So a topic branch is a branch in which you're like, I'm going to resolve one specific issue, right? So if you choose to tackle one specific issue and you create a new branch and you solve that issue in that topic branch and work in that topic branch, that's infinitely better for the health of your repository and for the sanity of your coworkers, right? So step 1, create a topic branch. Step 2, work in that branch, implement whatever code you need to implement. And then step 3, when you're done, you want to make a pull request to your main branch, right? So what a pull request is basically just a request to merge your topic branch and main, right? So basically it'll take all of the changes that you've done here and then just yeet them here, right? So you'll be like, it basically gets added to that most stable version of your code. Cool. Why is this good? Because when you make a pull request, then that pull request has to be approved, which means inexplicably, hopefully, someone will look at your code and do what is called a code review, which means that they're going to look at it and be like, hey, why did you do this way? This is unclear. You should maybe put a comment here. There's a better, faster implementation. There's something else in the repo that already does this that you can just extend and use, right? So that's generally how product development works when you're working in any kind of engineering organization. Because if a bunch of people are just pushing a bunch of code that no one else has looked at, or if you're all pushing to master, again, you're all working off of the most stable version, which means if you all try to push at the same time, like you might get something called a merge conflict, which means that like the versions of the code that 2 people have been contributing on are different, right? Which is like very unhealthy and very bad and very unsafe. Because then you guys have to like go through and comb through it and be like, shit, I need to make sure not to delete any of my code or any of the other person's code. So working in topic branches and like merging with master like every once in a while is a lot safer and a lot faster and a lot, like code review is very important, and making pull requests and creating topic branches is the way that you do that shit. So that's like in, I think like 5 minutes, 5 to 7 minutes, maybe 10 minutes, how version control works. Cool. So we can do one of 2 things. The first option is an optional exploration of all of the shit in practice. I can open up some GitHub repos from my personal GitHub and like show you like the difference between the 2 things. Or we can skip past this altogether and just jump straight into Q&A, and I can clarify anything that I've said that does not make sense. Which one would y'all prefer? Feel free to raise your hand or drop a message in the chat.
We have a bit of time, so I think the optional stuff could be helpful.
Cool. Everyone into that?
Yeah,
I see. Cool. Three other people besides Johnny have nodded or vocalized that they would like to see this. 4 now. Thank you, Rahul. So I'm gonna open GitHub. Cool. Cool. This is my GitHub, or this is my new tap screen. But this is my GitHub. Once it loads. Cool. I have a lot of code. Did you just call me a weeb, Rahul? Somebody kick Rahul off of the meeting, please. Cool. So I'm gonna open a project that I worked on called Screenplay Tech, which is basically like LaTeX for writing screenplays. So here's what this looks like. Yeah, cool. Can you all see this code? Do you want me to zoom in? You can see is that it? Yes, you can see. Okay, cool. So yeah, like here's some JavaScript. Cool, look at it. Wow, so great. So great. Cool. And then tag ID. Cool. Look at this. It's a fucking mess, right? It's like 198 lines of code. I wrote this code on a bus back from Boston the summer after my freshman year, and I can barely tell you what it does. Yeah, it's like a lot of if statements, and it sits inside of a like event listener, and it's kind of just like a mess in general. So yeah, like how about this? I will drop the link to this repo in the like chat, right? And then I'll give y'all 5 minutes to tell me what something does. How does that sound like fun? Yeah, cool. Let's do that. Cool. Feel free to turn your mics on at any time, or like drop something in the chat once you like it can explain something.
Yo, Ali,
Yeah, Johnny?
how verbose do your comments on your code usually have to be?
I try not to be like super duper verbose. Just like again, like your code should generally be self-documenting, whatever that means. Like somebody should read it and be able to like it's someone who's code literate should be able to look at it and like understand what's going on, just very broadly. But in the past, because my code was not self-documenting, I would leave a shit ton of comments everywhere. As you can see in like the function tag ID, right? It's like a lot of substring stuff, and it's like not easy to understand. So I'm like, cool, this is how you find the first parenthesis. This is how you find brackets, and so on and so forth.
Okay. Because I was thinking like, you obviously want to show that you have good coding practices, so you comment your own code for your projects, but also like you're the one who made it. So like, how verbose do you actually have to be when you're like talking to yourself? If it's like decently coded.
Feel that. But yeah, cool. It's been like 2 or 3 minutes. Anybody? Is this for like a play or something? Good question, Rahul. No, it's for writing screenplays. Usually I ask myself if I could understand my, okay, dope, fire. Cool. So let me show you a demo for this. Ali Muhammad. Why is that how my name is spelled? .io/screen. This should be like that. Do. Nope. So it's with a Y. That's unfortunate. Okay. No? Is it how it's spelled? There we go. Cool. So this is how this works. Let me see if I can expand this. It's like a very quick and dirty application. Cool. How does this work? Like that? Yeah. Yeah. So in my sophomore year, I took a class called screenwriting for television. So if you write TV or movies, you need to write something called a screenplay that has like a very specific formatting. So I just wrote like a bunch of fake LaTeX commands for screenplay front end shit. So you could do stuff like this. See, right? No, yeah, that should work. So if I write Rahul, is this for a play or something? Yeah, cool. So it's a bunch of like, yeah, and then there's a ledger for the commands and what each command does and how it should render it. So yeah, like this is what the app does. Sam says your code smells. Right, you are, Sam. My code does smell because I wasn't using static typing, object-oriented programming, or good version control. Thank you. Thank you for shitting on former me, Sam. I really appreciate the opportunity to reflect on my own growth. Um, smiley face, fire. So yeah, like I think that I've like beaten this dead horse enough. Like this code is really, really, really hard to read. Like Sam is, I think, the most proficient front-end developer I've ever met in my life. Which is saying something because I've been to something 50 hackathons, impact fellowship, yada yada, blah blah blah. Like Sam is the best front end I know, and he is like, this code is very hard to read and not fun. So that should make sense. So now let me show you what a good project looks like. Cool. Just a heads up, nerd alert. This is going to be like very D&D related. So like, I will try my best to describe it in terms that make sense. Johnny just said, woo, hell yeah. Shout out Johnny. Cool. So this is a project that I built that's called Tabletop. So basically, if 0 out of 10, there's no readme, go fuck yourself, Shrija. You are absolutely correct. I will add a readme very soon. But yeah, that's very valid. So very broadly, Dungeons and Dragons, or D&D, is a tabletop role-playing game / creative writing exercise where you are basically the main character in a story, and then you sort of just decide what you're going to do in the world and like create an adventure for yourself. So to create a character, you need to pick very important things, such as what race your character is, what class they are, like what items or background they have, yada yada yada, blah blah blah. So very briefly, I'm going to be showing what my like the race section of the character sheet builder. So cool. So going back to like this concept of inheritance, right? We have a class race that has a bunch of stuff. So name, age, speed, size, what languages they know, what traits they have, weapon proficiencies, armor proficiencies, tool proficiencies, yada, 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 blah, blah, blah. This is all huge nerd stuff. And then we have a bunch of helper functions. So add languages, add features, add weapon proficiencies, add armor proficiencies, add tool proficiencies, and then this big apply function, right? For all intents and purposes, you don't need to worry about this. But yeah, like cool. You have a bunch of helper functions that modify these like properties. So yeah, that's like abstractly, this is what a race is. It's a bunch of like languages and ages and sizes and a bunch of random information, right? So now let's look at a random class. Let's look at Tiefling, right? So right off the bat, export class Tiefling extends race. So constructor, super, Tiefling, 100 years. So the name of the class, the name of the race is Tiefling. Age, 100 years. Speed, 30. Like size, medium, languages, common and infernal. Here are a bunch of traits that you know. And then here's a bunch of empty arrays for stuff that you don't know, right? So yeah, quite literally, this is everything you need to like implement the Tiefling class, right? Like to represent that part of D&D in code. This is extra stuff that I don't super feel like explaining. So let me find a race that truly is like just that, like an extension of the base class. I think half orc works. Yeah, cool. So yeah, like this is 36 lines of code. If you don't count like empty lines, it's maybe like 30 lines of code. And if you don't count import statements, it's like 25 lines of code. And all of this could be one line instead of like 13 lines, right? Or 14, 15 lines. So really this is like 10 lines of code, right? Like super simple. Truly, like it makes this sort of like implementation really easy. That's how like now you see the value of extensibility. Does this make sense? like if I like, let's say that I didn't extend like class race to implement half work, right? Like this file would be just as long as this file, right? So let's look at it. Like this file would, like every single file would be 88 lines, but instead the other file is only 30 lines, which really only need to be 10 lines. Pretty cool, right? Object-oriented programming is really good. Also, like this is like you can see that all of this stuff is statically typed, which has been very valuable for a project like this because if we go back to source, right? Like there's a bunch of different stuff that needs to be implemented, right? So feats, races, classes, a bunch of base stuff, a bunch of background stuff, right? And all of this stuff is super long. Jesus Christ. Cool. Remember how I said that every single class should be its own file? I did not do that here. Every single class is in one big file and it's 362 lines long. But otherwise, each one would be like, I don't know, 20 lines long. It's pretty good. So yeah, like this would be like 20 classes. This would be, races would be like, I don't know, another like 10 classes and so on and so forth, right? So if these things were not statically typed and I tried to use them together and there was a bug anywhere in the repo, I would have to like manually search for where in the repo it like breaks. And now I don't because I wrote this code in like a pretty good way. So I think that that's everything that I have for y'all. I'm more than happy to talk about my own project for a while. I am more than happy to answer any general questions that y'all might have.